Hello everyone, welcome to the ITLS Academy. Today we are going to perform another experiment, that is your detection of the preservative. Now here the preservative that we are going to detect is a mercuric chloride. So before starting the experiment, we have to know that what is this preservative are. See, preservative is simply a chemical which is used to preserve the food product, or you can say that a chemical which is used to increase the shelf life of the food product or extend the shelf life of the food product, that is called a preservative, and the process is known as a preservation. So this is simply the preservative R. Now why this preservative act as a adulterant? See, when excess amount of the preservative are added into the food product, then that preservative are and then that preservative have a harmful effect, and then it come under the category of the adulterant. Okay, the FSSAI like they have a list of the permitted preservative and their limit values. Okay, if we added the preservative beyond that limit value, then that will act as a adulterant. So here the mercury chloride are added into the milk for a preservation purpose. But if it is more than 0.5% mercury chloride are added into the milk, then it acts as what? It acts as an adulterant, and it is very dangerous for the health of the human being. They have a toxic nature, and they are highly toxic, they are corrosive, and they damage the kidney of the human being. And even it the poison of the mercury included like your tremors, trouble in concentration, and gum problem. So that's why it is very important to detect that our sample contain this mercury chloride or not. This experiment is very simple. We require this setup. Like first of all, we required a dilute HCl, that is 1:1, which means that we take a concentrated HCl to 1 ml and we dissolve it into a 1 ml of the distilled water. That's how we prepare that dilute HCl. Now when we handling the concentrated HCl, we have to take a extra care, like we have to wear a mask, we have to wear a glove and a lab coat, and we have to avoid it to come in direct contact with this concentrated HCl. Otherwise it will damage our skin, damage our eyes, and also burn our skin. Okay, then we required a 15% of stannous chloride. This is your 15% of stannous chloride. Now how we prepare this 15% of stannous chloride? It is very simple. We take a 15 gram of stannous chloride and dissolve it into a 100 ml of that dilute HCl that we already prepared. Okay, then we required a sample milk. This is our milk sample. Then we required a micropipette of 1000 microliter, or you can say that 1 ml. With the help of this micropipette we add a milk. Then we required this micropipette tip, that is test tube stand, test tube holders. Okay, test tube stand, test tube holders. Then we required a dropper and spatula. Now what we have to do? We take a sample. Here we take a 10 ml sample, and into 10 ml sample we are going to add a 1 ml of the that is dilute HCl. Then we mix it properly, and after mixing it, we when a curdling occur, then we filter it, and then we collect that filtrate, and into the filtrate we are going to add a 1 to 2 ml of this stannous, 15% of the stannous chloride. And if that mercury chloride are present, then the then a gray color are appear. This gray color indicate that the presence of the mercuric chloride. So let's start the experiment. Now what we have to do, first we take a test tube. Now in a test tube I am going to add a 10 ml of our milk. See, okay. Then in 10 ml milk we have to add a 1 ml of the HCl, dilute HCl. Now mix it properly so that curdling form. When HCl are added, it converted the milk into a curd. Now take another test tube. We also required a filter paper. With the help of this filter paper, we filtrate that solution. Now put that funnel into the test tube. Now add now we get a filtrate very slowly. Now they see, after filtration we get a filtrate which is a milky color. Now I am going to add a 1 ml of this 15% of stannous chloride. If that mercury chloride are present, then the solution turn gray, and if it is not, then it will be a same in color. See that after the addition of that mercury chloride, our solution does not turn into a gray color. It is already a milky color, which indicate that our sample does not contain any mercury chloride. Okay, so this is about how we perform the detection of the mercury chloride into a milk sample. I hope you will understand, but if you have any queries related to this experiment, you are free to ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platforms. That is your Instagram, Facebook, Twitter, YouTube, WhatsApp and LinkedIn. And subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. You can also visit our website, that is www.itlsacademy.com. Thank you for watching. Please like, share and subscribe our channel.